Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, we're going to continue to build on the L298N. We're going to add the Nextion display because mainly this channel is focused on the Nextion and I want to incorporate that into it. We're also going to add forward and reverse. And I'm going to tie this into a little toy that I have where I made a windmill out of what's called Lux blocks. And so that way it'll be a little more fun. This video is going to pick up exactly where the last one left off. And I'm going to start in the Nextion, and we're going to just build a little interface for that first. I have a pretty simple display. I can't exactly remember the model number, but that shouldn't really matter. If you were to download it, you could run it in the simulator, or just pull it up and run it in debug, I guess, not the simulator. And then you could copy it to your own display if you wanted. I made it pretty generic. You should be able to use any display for this. I'm going to add two buttons. I'm going to add a dual state button. I'm going to add one number and a slider. And then I'm going to add two variables. And now we'll just move them around. With the latest version of this Nextion, it's made this be a 3-color slide, which is kind of interesting. I don't know what other features came out of the new version, but at least that's kind of neat. We're going to take the variables and we're going to name one text and we'll set them both to strings. But I'm going to name the other one value. You don't need to worry about making them global. This is just going to be a one-page form. You do need to make sure there's a font in there. And then I'm going to kind of breeze through. I'm going to make one of these buttons forward. I'm going to make one reverse. I'm going to have the dual state button be stop and start. And then I'm going to have this show the speed that we're sending it. It's this number field. So I'm going to speed this portion up. Okay, so now it's pretty much set up. I didn't change any code in it. The only thing that I changed was I set these to strings, and I showed you that in the video. So I just skipped ahead to this part now. Now we'll start adding some code. And the first thing we want to do is in the post initialize of the main page, we want to set this N0 equal to whatever H0 is. And H0, we want to set the range on that. And the normal range is 0 to 100. But in this case, we're going to do this pulse width modulation on the motor. And we know the max value is 255, because that would be always on. But in this case, we're going to set the min value at about 120. Or no, let's set it at 80. Because we know we have problems when that motor gets below 80. And now we're going to set this somewhere in the middle. So 255 minus 80 is approximately 170. And 170, let's say 160 divided by 2 is 80, so we'll just put this at 160. It's not perfect, but it's close to the middle. And that'll be our start value of this. So when we first run this in debug, it should set this value, this number value, to 160. We can run that real quick just to see in debug. And you can see it's set to 160. But as we move it, nothing's going to happen because we really don't have anything happening yet. So now we want to add the code to each one of these buttons. And I usually do it on touch release. And I'm going to go over this kind of quickly. I have a video on Covex, but what we'll do when you hit this reverse is we're going to set this value equal to whatever HO is. So if we've adjusted it, we're going to set that value to it. And then we're going to take that value and we're going to store it in the value variable. And then we're going to set text equal to REV for reverse. And then we're going to add or append the value. Oh, and up here I also have to point out we're making it 3 digits. So let's say it's set all the way down to 80. It's still going to be 080 rather than 80. So that means that this rev would be, we'd add that to it, it would be REV 080. And then we're also going to put this colon on the end of it, and then we're going to add that just as a delimiter so that we know at the end of the command there'll be a colon, and we'll do that on every one of them. And then we're going to print it out the serial port. We're going to print s text.txt, which is the value that we now have in there, which, as I said, for the case of 80, it would be REV 080 and then a colon. We're going to do almost the exact same thing on the forward. The only difference is we're going to have FOR, and every command that we send is going to be 7 characters long. Even the start command will be 7 characters long. And we're going to add that start one next here. But remember, this is a dual state button. So now this code can be a little bit confusing. You almost have to see it work first. But we're initially going to send or set this value when we press it to start, even though it already is start. We're going to set it to start, and we're going to send the stop command to it. So that means it's not going to be on when we first turn it on, and we're going to tell it to stop. The first thing we're going to do is tell it to stop. But the next time we push it, it'll start. Because it will turn that to a 1, and then the next time through it, it'll be a 1, we'll change it to stop, and we'll send the start command, which is STA, whereas up here the STO will be stop and STA will be start. And then we're also going to send the value of H0 just like we did before, and we're going to follow it with a colon. I'm going to go ahead and run this in debug right now just so you can see what I'm talking about. So I'll start the simulator here so we can see what happens. When I hit the start button, we're sending the start signal, STA 160. Oh, it must be set to a 1 and not a 0. So it sends the start, and it sends the value that we have here. If I adjust this, and I hit stop, it's going to send STO 214, which is the value of the slider. And when I hit start again, it will hit STA 214, which is the value. If I hit reverse, it's going to hit reverse 214, and if I hit forward, it's going to say forward 214. Now we have to set it so that it changes the speed when we move this slider back and forth. When you mess with the slider, you have when you press it, when you release it, and when you move it. And what I found, if I do anything on the move, I copy it over to the release, because something happens funny when you go to release off of it. It doesn't always get that last movement. So I'll copy it here, and then on the move I'll put the exact same thing there. And what we're going to send is SPD for speed, and then everything else is the same. And that's really all there is to the Nextion portion of it. We're sending 7 characters, we're changing 3 of them to let us know what we want it to do, and then every time we send something we're going to send whatever the speed currently is. Now we'll move on to the Arduino. Now for the Arduino, as I said, we're going to pick up right where we left off. So I'm going to have to comment some things out and uncomment some things to make it work. But I want to keep going the way we've done it, and I'm going to keep the code that we had before. So we're going to switch over to the Nextion display, so I need to uncomment this second serial port because I'm using a nano. The motor itself is going to stay the same. We're still not going to use 3 and 4. We are going to use the pulse width modulated pin this time. I think in the last video I used N1 for the pulse width modulation, and we were not reversing the motor. We were only going one direction. So since we're going to be switching directions, we will be using this pin 5. We're going to not use 8, 9, and 10. And for the direction, we're going to need these variables. The motor direction is going to be 1 for forward and 0 for reverse. We're going to have the pulse width modulated rate, and we're going to have an enable so we can start and stop the motor. The Hall effect is going to stay the same, but this rotary encoder, we're going to go ahead and comment it out. The setup is going to stay the same, except for the rotary encoder. But like I said, I want to leave it in here so that you can go back if you need to. Now in the main loop, we have quite a bit with the rotary encoder, so we'll just do the same thing. We'll just comment it out. But that rotary encoder also has the switch, which we were using to turn on and off the motor, and now we're going to use the Nextion display, so we'll get rid of this too. So pretty much all we've done is enabled the serial port. Oh, I do need to go up and enable it in the setup too. Right here I need to uncomment out this. So now we're going to pretty much just go back to the standard default Nextion that I used in the past. And so I'm going to uncomment out, because we're going to collect the data. So I'm going to uncomment out these lines here. So we'll be collecting data from the serial port. It'll be coming from the Nextion, and we're going to store that data in this, what I call data from display, and I just have it abbreviated DFD, just so I don't have to type as much. As the editor will tell you, I'm pretty lazy. Not as lazy as the editor, because all he does is second guess my work, I guess. But the Nextion is going to send 7 characters for every statement or everything it wants the Arduino to do. So we're going to check for a length greater than 6. That means we've got 7 characters. But sometimes it'll get out of whack. It'll send an extra character or something will happen and it just won't see things right. So we're going to put a little error correction in there. So if that 7th character, if it ends with the colon, which is what we're looking for at the end of the command, and the length is 7, then we're going to do what's within these quotes right here, or these curly brackets right here. If it's not, if it's greater than 7 or greater than 6, but it's not equal to 7, and it has this colon at the end, which means it's gone to 8 or 9 characters, and we finally see that colon, we're going to print it out, the DFD, and we're going to reset it, because that means that something's gotten wrong. But if it is 7 characters and it ends in a colon, then we know we want to put something between these curly braces right here. And the first thing we'll do is we'll print the DFD, just like down here. That'll just give us confirmation on what we've received from the display. And if we look at the substring of the data from display and we see FOR or REV for forward or reverse, then we know we're going to set the motor direction variable. And for forward we're going to set it to 1, and for reverse we're going to set it to 0. Now if in those same 3 characters we see STA for start or ST0 or STO for stop, then we're going to set the motor enable to 1 or 0. Now the last thing we're going to do is look for the speed. So if the first 3 characters are SPD, then we're going to set the motor pulse width modulated rate, that variable, and we're going to look at the next 3 characters and we're going to convert it to an integer and we're going to store it in that variable. And then just to make sure we got everything right, we'll print that. So we're going to print this line. We're going to print the direction, whether it's enabled or not, and the speed. And then we'll reset the data from display. So we're going to print the data from display up here. Then we're going to print this other line down here, which is going to give us some feedback. And then we'll clear out the data from display. But all we've done so far is collect and store variables. We haven't done anything. We haven't sent any output to the motor controller itself. So here we're going to see if the motor's enabled. So if it's enabled, we'll do the first part. But if it's not enabled, if it's a 0, we're going to set N1 and N2 to low, which is just going to stop the motor from running altogether. But if it's enabled, then we have to do something different, because we also have to determine the direction. So if it's enabled, we're going to analog write the pulse width modulated rate, which is going to be 80 to 255, to that pin, to the pulse width modulated rate pin. And then we've got to set the direction. And all we have to do is check for the pin itself, or for the variable. So if motor direction is 1, we're going to set N1 to high and N2 to low. Now if motor direction isn't a 1, else, then we're going to flip it. We're going to set N1 to low or N2 to high. So we're going to check if it's enabled. If it's enabled, we're going to set its rate and set its direction. And down here in the async delay, which we have set to go every 1 second, I believe from the last video, I could go up and look again, but I think it's every second. That stays exactly the same because we're going to read that Hall effect and we're going to print out our current pulse width modulated rate, and we're going to convert it to an RPM. Now I haven't done anything to correct the math on that. It's still not a correct RPM, but it'll give you an idea of what we're looking at. So now I'm going to go ahead and upload this to the Arduino and see what happens. So here we have our serial monitor running. I'm going to shrink it down, and I'll leave auto scroll on so we can see what happens. But right now we don't have it on. I'm going to start it. I had to adjust the speed a little bit there. And I'll put the camera on it here in a minute. You can probably hear it in the background running. But you can see that we've got a speed. We have the pulse width modulated rate. Okay, and you can see that I have this windmill going. I can't do the display and everything all at once, but so you just have to trust that the display is going. But I'm going to speed it up here. And now you can see that the pulse width modulated rate is at 194, and you can see that it's picking up speed. And the way this thing runs, there's a belt on the back of it, so that could pop off at any point now. So if it does, I'll just have to pause the video for a minute and hook it back up. I'm going to slow it down now. And now we're going about 141. I don't know if it can go all the way down to 80 or not, or if it'll stall. Oh, it stalled. So 90 doesn't work. Let's get her spinning again. There's 122, and that's too slow too. Looks like 142 runs okay. But now we're going to switch directions. And you can see here where the direction went to 0, enable is 1, and speed is 142. I'm going to start the auto scroll again and hit the direction again, and you should see the direction go to 1. Oh, here's a good example of where it got the wrong information. So it wasn't able to do anything. But now it went forward 142, direction 1, enabled 1. If I hit stop, then you see the direction's still the same, but the enabled is 0 and the speed is still the same. What's interesting, when I hit start, it can't start at 142. I need to speed it up and then bring it back down. I'm kind of surprised that it can shift directions at 142 when it wasn't able to start from 142. So that's kind of interesting. But now I want to show you something else. I'm going to set this at 1 speed. I'm going to set it at 150. 151. Let me set the auto scroll on. And we're going to let it stabilize here at about, looks like about 4080. Well, 4044, 4080. Like I said, it's not the most reliable. You can see that the Hall effect is right here, and it flashes when the magnet goes by. But I'm going to expand the this windmill, and I'm going to put more pieces on the end, and you'll see what happens. See if that 150, if it still spins at 4080. Okay, so now as you can see, I've added 2 more lux blocks to each one of the fins on this. I don't know if it'll have enough power to start it, but I've left the speed at 151. And it does. So let's see if it makes it to 4080. It's taking a lot more time to get up to it. I might time-lapse this a little bit. Or it may just be set at about 1200. And so you can see it's going to take more power to have that go at that other rate. And that's where I want to, on the next video, I'm going to try to add some proportional control so that we can set the RPM that we want. If we want it to be 3000 RPM or 500 RPM, we can adjust the speed of the motor or the pulse width modulated rate to hold the RPMs. I'm going to turn this up a little bit and see what happens. So now at 215, we're at 2880. I don't even know if I can get to 4080. The whole thing may just fly apart at any minute, so we'll see what happens here. So it looks like at 2050, which I guess I can't get it to go to 2055, it's stuck at about 3840. So we'll have to play with our speed a little bit, or maybe only add one block between the two. And you can see here, let me stop this. I hit stop here and it was wrong, and then I had to start it again, and then I hit stop and it made it. So that error correction is pretty important in the data transferring between the Nextion and the Arduino. So in the next video, I'm going to add RPMs into here so we can see what the RPMs are on the Nextion display. And maybe I'll run it in debug mode so I can show it on here. It's hard to put two cameras on this on the computer setup the way I have it. So maybe I'll just, like I said, I'll run this in debug or something and have it connected through a serial port to the Arduino. And to recap for this video, we made a simple control to send REV and FOR, STA, STO, and then the pulse width modulated rate to an Arduino. And then in the Arduino, we read that data in, and based upon those first three characters, we set variables, and then we use those variables to send commands to the L298N controller. So it's pretty simple at this point. Now once we get into the control of it and the feedback, that's where it can get a little bit tricky, and I think a little more fun, and especially if we can add even some more blocks to it and get it to fly into pieces or something, could be fun. But we'll see if it goes there or not. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.